Also, I don't know if I advertise this as a service to you because I love you all so very much. I post these lectures on YouTube. I strongly encourage you, do not overly lean on this. If you want to go back and revisit something that is unclear in your notes, you can use those. But I mean, seriously, who among us actually learned stuff as well in COVID during all that freaking online time? Videos and online learning suck. It's better for you to be here. Okay, I'm not going to preach though. If rewatching things is your style, if that helps you, that is available. I post those videos on YouTube, and the links are posted on the main page of the class, the main Canvas page. We have very little content, very little new content, and a heck of a lot of working on internalizing and understanding what's already what was shown on Monday, and also understanding what you did in lab. For those of you, just show of hands, who has already taken the lab for this week? Yeah, okay, so wait, oh, that could be everyone. Who has yet to take it? Okay, so there's still a bunch. Okay, so for those of you who've taken it, this is a review of some of the things that I certainly hope your lab instructors hammered down. And for those of you who have yet to take it, this will make your lab go smoother. So make sure to think about these things, and you guys will have an easier lab than the people who already started it. I don't know. Your mileage may vary. Okay, I'm going to just real fast sketch out the couple of things that are the couple of points that everything we do today is based on. Here it all is. Here, first off, here's the one and only new idea. Displacement, write this down, can be found by the measuring the area under a velocity graph. Example. Really stupid example. I go -2 meters per second, that is to say with speed of 2 meters per second to the left for 5 seconds. How far did I go? Oh, come on, you don't need to think about that. -10 meters, yeah? Meters per second times seconds is displacement. I can associate that with the area of a rectangle, where I say this base of the rectangle is represented by, it means the time interval. And the height of the rectangle, negative because it's below horizontal axis, the height of the rectangle, -2 meters per second, can multiply -2 meters per second, that's 5 seconds, means that area means how far I went. I went -10 because -2 times 5 is 10, -10, right? You agree with constant velocity that is like brain dead easy, yeah? Okay, so this might be a little more confusing. What if I only reach 2 meters per second, -2 meters per second at the end? If I speed up from rest to -2 meters per second. Something like that. I start at rest, and I speed up in the negative direction until I hit -2 meters per second. How fast am I going on average, by the way? What's my average speed? Average speed, average velocity, actually. If I start from rest, from 0, and end up at -2, what's the average of 0 and 2? -1. Right? What's the average of two numbers? Add them together, divide by the number of numbers. Average of 0 and -2 is -1. Okay, so if I'm going at an average speed of -1 meter per second, half the time I'm going faster, half the time I'm going slower. Average speed is -1 meter per second. For 5 seconds, how far did I go? -5 meters, right? So if I speed up steadily from rest to -2 meters per second, the displacement is -5 meters. What's the area of a triangle of height -2 and base 5? What's the triangle formula? Half base times height. Oh, remember that? Long time ago, yeah? Half base times height. Write that down if you don't remember it. What is half base times height? 1/2 of -2 is -1. Oh my goodness. See? Something like that. I think I give you all of 2 problems. Maybe it's even 1 problem that requires doing this on the homework this week. This is a lead in to something that's going to become terribly important next week. This is the tip of an iceberg, and we're going to go swimming and get to the bottom of the iceberg, maybe. Okay. What happens if velocity doesn't change steadily? Don't worry, I won't give you that. I will only give you 2 cases, constant velocity or steadily changing velocity. So you only need to find the area under little boxes or little triangles. If you know base times height, you know half base times height. That's all the formulas you need for this. Questions? No? Okay, so that's one thing. Now this isn't actually new information, but let's briefly review what does it mean to have a small position? What does it mean to have a big position? What does it mean to have an increasing position, a decreasing position? What does it mean to have a small velocity, a big velocity, all that stuff? And so let's talk about position graphs for a second. What's it mean to be down here? X's are negative. What does that tell you? Small what? Let's establish a coordinate system. Nimona is the origin. That's positive, okay? So the middle of the classroom is x equals 0. What are my x numbers right now? What are my position numbers? Negative. So what does negative values of position mean? What does that tell you? Say where you are located is to the left or below or to the negative direction of the origin. Position tells you where you are. If position is negative, you're left of the origin, or below the origin, or whatever the negative direction from the origin is. What does it mean if position values are up here? You're on the right side of the origin. Yeah? I need to scroll this down a little so I can reach. What does it mean if position values are getting further from the origin? Sort of gave it away. What does it mean if the slope of the position line is going away from the horizontal axis? I am moving away from the origin. Here I am moving away from the origin. The graph of my position versus time would be like this. I'm moving away from the origin. I'm moving away from the origin. Graph of my position time would be small values getting negativer and negativer. Yeah? What does it mean for slope to be positive on a position graph? I'm going which way? I am above or to the right of the origin if my values are positive. What if I've got a slope which is a positive? I am moving, if it's a constant slope, I'm moving at a constant rate. But just the fact that the slope is positive doesn't tell me I'm moving rightward. Write this down. Write this down. If you have a positive slope on a position graph, slope of position is velocity. The meaning of positive velocity is which way am I going? I'm going rightward or upward or whichever the positive direction for your coordinates is. What's my velocity right now? Positive or negative? Moving in the leftward direction, negative. What is happening to my position time graph? What is the slope of my position time graph? Started in the positives, got smaller, positive, crossed a Mono, went negative, right? The slope is negative, then the velocity is negative. Slope of position is negative, means velocity is negative, means you're moving leftward or whatever. You writing this down? Sure. Remember that slope of position is velocity. Plus or minus velocity tells you, are you moving right or are you moving left? Or up or down or north or south, whatever your coordinates are. I am moving leftward. My velocity is negative. I am moving rightward. My velocity is positive. My slopes were negative than positive. Yeah? Is good? What does it mean to have a steep slope on a position graph? Bah. Does it mean to have a shallow slope? How do you see stop being at rest? I would say a horizontal slope, a horizontal tangent line. Your slope passes through horizontal, or maybe stays horizontal. If you're staying at rest, your value is just some value staying there. If I just stop for a second and turn around, if I stop for an instant as part of the turnaround process, my slope would just be for an instant 0. Okay? Turn to your neighbor and discuss these qualities. What does it mean to have a positive position, negative position, positive slope, negative slope, steep slope, shallow slope? Turn to your neighbor and bang through these real fast. Chop, chop. Questions? Follow-up questions about position. You have a question, I can smell it. What's the hardest part of this? What's the most confusing part right now about interpreting these graphs? Come on, be bold, tell me, what's the hardest part? Let me encourage you to think, whenever possible, think about the meanings and forget the words. If the words are secondary to the meanings. If you are able to interpret, oh, there we go, here. Can you interpret in terms of fast or slow, left or right, up or fast or slow, left or right, towards or away? What is the motion that this graph looks like? Rightward motion, and what else can you say about it? To the left of the origin. What could you say about the fact that the slope is constant? Constant speed. So I could describe this as rightward motion from the left side of the origin at constant speed, constant positive velocity. Does that help? A little? Good. I'm about to make it worse. Wait, one more thing about position graphs. How would you see speeding up? Yeah. Say more, say more. If the slope is going into the horizontal, that's slowing down. Steepening, upward or downward. Going from shallow to steep. You're absolutely right that it's an incline, just the opposite sense. How do you see slowing motion on position graph? Shallowing, yeah, shallowing in general. Last bit of new information, and then the rest is going to be me shutting up, except for telling answers. It's going to be you doing. What does velocity on the horizontal axis tell you? If velocity values are on the horizontal, describe that in words. Not moving. If you're on the horizontal axis or you touch the horizontal axis, the values are 0, you're not moving. What does it mean to have velocity values close to the horizontal? Slow. Far from horizontal? Fast. What does it mean if you're sloping away from the horizontal? Sloping towards? Good. What does it mean for slope to be positive on a velocity graph? Does it mean always speeding up? Say you've got a velocity versus time graph that looks like this. What's going on there? Turn to your neighbor and discuss for a second. All righty, let's hear from y'all. Who's bold and willing to say it out loud? Yeah, say it loud. It does mean you're accelerating. We're going to talk about acceleration proper next time. Can you tell me about the fastness, slowness of the motion? When do we know it's fast? When do we know motion is fast on a velocity graph? Look at your notes. What did we just say? Fast motion when v values are away from 0. So what does it mean that we start with big v values? Are we moving fast or slow? What does it mean that we're negative velocity initially? Leftward motion, I would say. Motion is going left. So we start out which way and how fast? Leftward fast motion, but then slow down. Watch out, watch out. It's very common for students to think you've got an upslope, that means you're speeding up. No, 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 no. Values of velocity are getting closer to 0. Here I come to rest for an instant. Yeah, you see that? This is slowing while moving in the negative direction. Sketch this down on your notes. Slowing while moving in the negative direction. What happens at the instant we cross horizontal axis? We're at rest. And then what do we do? Speed up in which direction? Rightward direction. Here's an example of this motion. No, it doesn't depend on me starting in the positives. Same motion can be here. Okay? I'm gonna kill myself one of these days doing that. Trip over my shoelace. Turn to your neighbor and describe the meanings of the velocity graphs. How do we see, how do we know, why does it mean what it means? And then I'll take a question. Where's it go? Turn to your neighbor. Hey, follow-up, by the way, from Haneen. Does negative slope, sorry if I butchered that, does negative slope on a VT graph mean deceleration? No, 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 no. Very common, easy to make goof. Means negative acceleration. Negative acceleration is not deceleration, as you might think. Deceleration, slowing down, means velocity approaches, velocity values get closer to zero. Negative velocities increase, positive velocities decrease. If the velocity graph is approaching the horizontal axis, that's slowing. That's deceleration. Okay, now follow-up questions. Y'all talked to each other. Surely someone discovered that they didn't really understand Marco's question. Follow-up.
What would the velocity graph, if you transferred it to a position graph, look like? Or just that straight line?
For this straight line, let's construct this. If I start with large negative velocity, that is telling me I start with a large negative slope. If my velocity decreases, that means my slope shallows. Sorry, velocity increases, speed decreases, velocity approaches zero, my slope shallows. As my velocity does not necessarily touch the origin, as my velocity values hit zero, that's a turnaround point. There, this is what that position graph that corresponds to this velocity might look like. If you've done the lab, you'll recognize, you saw this. This is the velocity graph for an object rising up towards a motion sensor, then turning around and speeding up away.
That on the position graph, is it just the shape? Or do you know, like, if it's actually close to position zero or the origin?
Very good question. You cannot tell just by looking at velocity, you cannot tell where an object starts. So go back to my previous statement. Notice my very first statement. Displacement is the area under a velocity graph. You can only find displacement, change in position from velocity. Whoa, you cannot find where you are, only how far and which way you've gone. So I don't know. This position motion and this position motion both correspond to the same velocities, same velocity profile. Good question. Have you taken calc? Okay. For people who've taken calc, this is the plus a constant. You take an integral plus c. The plus c is the original value. If you haven't taken calc, don't worry. Okay, other questions about velocity. You're about to do a bunch of practice. No? Okay, let's get to the slides. Slides proper. Okay, you did this before real fast. So this will be object, so not real fast. Take a minute and remember, put this in Google Form B. You can talk to each other too. Tell each other why. Tell me why. You get an A. Not an interval. D. If you put D, then you know the D correct answer. Eh? D is the fastest it gets. Remember, you could tell velocity by slope, magnitude of slope, the steepitude is the speed. So at A, it is slowing down. B is turnaround point, C is speeding up, and it continues speeding up. It's subtle, it doesn't look very strong, but you can indeed see that this point is less steep than this point. C is the fastest it gets. C. Turn to your neighbor and discuss. When on a position graph do we know we are moving leftward? There may be more than one correct answer. Gesundheit. C, D, E. Hey, by the way, a number of people in my 3 o'clock asked why it is C. C's values are positive, but position values don't tell you the direction of motion. Velocity values tell you the direction of motion. Think about it this way. Here's a practical example. I was in Tempe, East Valley. I was in Tempe. Which direction was I driving? Well, not necessarily, you don't know. I mean, not from here to Tempe. If I drove from here to Tempe, yeah, my displacement is positive. But if I just tell you, I live in Tempe, I drove to the store, which way did I go? Oh, just knowing the value of position is east of central does not tell you if I'm driving eastward or westward or northward or southward. The position at a point, knowing the value does not tell you which way it's changing. So if you want to know the But if you want to know the direction of motion, it doesn't matter if you're positive, 0, or negative. It doesn't matter if the value is positive, 0, or negative. It depends on the direction of change. C, D, and E, I am all decreasing position. Position is going towards negative infinity. I'm going down. I'm going leftward steadily, not steadily. Faster than slower, but still. Questions? Give me a follow-up question. I hunger for your questions. I'm a question vampire. Yeah, please. C, D, and E. A, it is most definitely positive slope, moving in the positive direction, positive velocity. It's another question. Yeah. Yes, good. Notice the value of F is negative. I'm in the West Valley. Which direction am I going? You don't know. If I'm in the West Valley and staying at the same street, which direction am I going? If I'm staying at the same position, which way am I going? I'm not moving. I'm staying at the same place at rest. Good. No, that's not what I want to do. The D. Yeah, I know it's hard to think at 5:04 in the night. Suck it up, Buttercup. You can do it. It's good for you. Suffering builds character. Can you look at it? Sure. Oh, I should have asked first. A student knitted that for me. I know, right? Did you see the movie? You got to see the movie. Nimona. It's amazing. I'll give you an A if you see the movie. Just kidding. Yeah. Yeah, it's great. Make sure to watch it with very conservative family members. Yeah, by mistake. She lives in my office. Okay, let's see your answer. C. Oh, I'm so happy. C is, as we say in Spanish, C. Okay, we are going from shallower to steeper. I mean, you should actually think about this. If you know D is the fastest point, C is approaching the fastest point, right? Follow-up question? Correct answer is C for speeding up. And now some questions where I've gotten it's one line, but two. Sometimes students say which one is which. Car 1 is the red, car 2 is the blue. Give me E, give me F. Please, please, don't just give me. Please give me. And I'm going to ask someone to explain why. Sometimes it takes me a while to enter them. If you will know by doing, if you are entering more than half, of the things, making a good faith attempt without putting like IDK, 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 or like if it's a key match 0, 0, 0, 0, 0, then I'll know you're sleeping on the keyboard. If you're making any reasonable attempt, or remember, you can also always, full points, ask a question. Tell me where you're confused. That's very valuable to me. You can always, if you don't feel comfortable raising your hand or whatever, this is to apply for anyone. Asking a question in the Google form is very useful to me. No, 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 no. That's fine. No, 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 no. No, I don't grade based on correctness. I based on, are you making an effort? No, no, absolutely not. Okay, can I volunteer someone? Will you hate me if I volunteer someone? Marissa, would you be willing to explain why you answered what you answered? Be precise. What intersects? That's correct.
The second one, I said never stops, because it's always.
Velocity. Slope of position is velocity. Does anyone see a place where this velocity horizontalifies, becomes horizontal?
Seems to me that C was pretty level up.
That's car two. Car one, trick question. B, it passes through 0, but here, I will walk what where's Nimona? Can I have Nimona back? Thank you. Okay, I will walk the path, the trajectory of car two. I start in the negative values. I slowly and steadily walk. Here's B. B is when I pass her. Did I stop? Was my velocity changing at all? Slowly and steadily in the positive direction. That was the slew. Nope, nope, nope. No. Position graph. Consider the volume position time graph. If this were a velocity graph, you betcha this would be stopping. Then the motion would look something like this. Moving in the negative direction, slowing down and turning around. That would be if this were V. This is X. Do you guys know the difference between X and Y, by the way? What's the difference between X and Y? X is someone you dated, a Y is someone you're embarrassed to admit it. Okay, GH. Wait, not G, yeah, GH. Give me your best shot, fire away. Oh, let me volunteer someone else. You had such a good answer. Let's poke somebody else. Isabella, can I volunteer you? I don't know who Isabella is. Isabella, are you willing to speak? Tell me what and why. Correct. Why? Good. Hey, what about D? Not only did they cross, aren't those about the same steepitudeness? Steepification? Does that mean they have the same velocity? Couldn't have said it better. Perfect. Same speed, but opposite directions, opposite velocities. One is positive, one is negative. Good. Good, good, good. I think you guys are rocking the Casbah, rocking the position graphs. Let's go into velocity land. Yeah, question. Correct answer was C. Yeah. No. Sorry. G is C. H is A. You don't have to change your answers. Remember, everyone, the participation form I grade on, are you entering stuff? Are you making an attempt? Are you awake? Not the correctness. You don't have to go back and edit them to change your answers. Okay, this is a hard one now. We're entering velocity land, velocity time graph. You can use your notes from the very beginning of class if you need. And also, let me specify carefully that this is the instant after it leaves my hand, flying through the air, rising, falling, to the instant before it's caught or hits the ground or whatever. So in particular, not the throw, not the landing, just the flying through the air part. Okay, ready, set, go. Discuss with each other, like the cow with the farmer. Yeah. Let's see. Number 1, number 2. I already wrote down numbers, so. Well spoken, by the way. Good job. Isabella? Well spoken. Good job. What's that?
Oh, wait, I think three is yeah. Okay, so the hand is. Right? That it's unfortunately it's gonna have a falling sound. So.
If you've done the lab, you can look at your lab notes. What did it look like when the cart was rising along the track, turning around, and then descending again? Which velocity looked like that? No, now you're all confuzzled, aren't you? You're not double thinking yourself. You're double, what's that phrase? You're double crossing yourself? You're second thinking yourself. Okay, remember, what's it mean to go up? How do you see upward motion on a V graph? Motion is in the positive direction if how do you see on a velocity graph? How do you tell that you're moving up or rightward or whatever? Look at your notes. Look at your notes from the very beginning. Yeah. I can't hear. Say louder. Away from the axis, the horizontal axis means you're speeding up. Actually, we start slowing down. The instant after it leaves your hand, the rock slows as it rises, right? So we actually want something that approaches the horizontal axis. But again, How do we tell? Look at your notes if you need to. How do we tell that something is moving positive? What is in the positive? Be precise. The values are positive. So like 2, 4, and the beginning of 1 or the end of 3. If velocity is greater than 0, the values are greater than 0, then we're moving upward or rightward or whatever. What happens when you peak? What's your peak position? What does velocity become? 0. We cross the horizontal axis. Then we go back down. You're going down. What does that look like? Negative, what about the velocity? Negative values. Which of these starts positive, slows to stop, and then increases in the negative direction? Turn to your neighbor and discuss. 90% of you missed this. Turn to your neighbors and explain why. I'm going to take someone to respond too. Yeah, put this in I. Put your first guess in I. I'm going to see how many people. Next week. Next week. Even into the week after. Because free fall screws with people's heads so much. Well, that'll continue into week after. Remember, Monday's Labor Day. Okay, Jamal, could I get a Jamal to, can I volunteer Jamal? Yeah, can you explain why it's 1 in your words? True. So we start, did I say, yeah, so 1, the what goes negative? Be precise, don't say it. Yeah, but what about the rock is going negative? That's true, that's true. And what is the physics term the quantity for saying I'm going downward? You remember? Can someone else, do you know what I'm fishing for? Velocity. Velocity values go negative. That tells you you're descending. Okay, let me poke someone else. This is hard, and hard, but important. Caleb, can I volunteer a Caleb? Yeah, can you give your take on this? No, I already told you it's 1. I want you to explain why it's 1 in your words. Good. That's true. This maximum speed is the same as that maximum speed, incidentally. Also, the area under this part is equal to the area under this part. Anyone remember what the areas mean? So as far as it goes up, it will also come down. I mean, unless it misses your hand and 2 more, and then no, actually, let's do this. Let's do this now. Okay. I was going to do an extension to that, but yeah, Marcos.
I was gonna say, is the speed always gonna be the same when you shoot it up versus like, what if you shot it out of a cannon and it just, would it be still going to things?
That's why it's so darn dangerous when foolish, silly people shoot guns into the air on 4th of July. They come down with muzzle velocity. muzzle speed, I should say. Yeah. So you shoot a cannonball, when it returns to its original height, it'll have its original. To the extent we can ignore drag, air drag, if air drag is significant, then you will have slowing. A cannonball is really going to ignore air drag. I'm not sure about a bullet, how much a bullet cares about drag. So my answer, what I just said, is logically, rigorously, I promise, is true to the extent that air drag, air resistance is minimal.
Sorry, before the previous slide, would have number 4 been like a position graph?
Yeah, well, almost, except this describes a constant velocity up, then suddenly turning around with a constant velocity. As I throw something up, it slows down and then speeds up. It doesn't just go up, then go down. It's not an elevator. Yeah. Here is parabola, is the correct position graph. Okay. This one you will maybe appreciate, especially since it's 5:25 after been working your brains hard, I think. So I'm going to demonstrate the forced part. How do I find a position given, notice you have to be given the initial position. Velocity graphs can only tell you displacement. They can't tell you where you started. So I'm going to tell you the initial position and find where the object is at time t equals 1 second. The area under that trapezoidal region is the displacement from 20 meters. I hate trapezoids. Shoop. I'm going to cut the trapezoid into a rectangle plus a triangle. I promised you at the beginning that I'd only use rectangles and triangles. Here we go. If you get a trapezoid, cut it up. Put it up. This area here, that's a height of 8 and a width of 1. This displacement is 8 meters. This is a height of what? Is it 12? 4. From 12 to 8 is a height of 4 and a width of 1. What's the area of a triangle formula? 1/2 base times height, so that's an additional 2 meters there. Total displacement, final position, 30. Okay, I find the position is changed by 10. If I start at 20 and increase position by 10, 20 plus 10 is 30. Let's do it again, and again, and again, and again. After 2 seconds. No, you could do this. Question J. Find the question J. J is find displacement from t equals 0 to t equals 2 seconds. You do this, you do this. Tell me the area of that trapezoid. Talk to your neighbor. Should be louder in here. What area? Okay. So many correct answers, make me happy. Although, what I specifically asked is the displacement, not the final position. Many of you have told me final position. Answer the question I asked. Go back and edit your answer for this case.
Fair. In the question, it does say that.
It does, but the initial position doesn't change the displacement. Displacement does ignore initial position. You correctly answered a different question.
Like 20 minus the original 30.
He's always going in the positive direction. It's plus.
I mean, it's like when it was 30 on the first equals 1 minus 20 with the position of 10 in that case. Because we're finding displacement of position would be just the.
Why minus 20?
From x equals to 20 original.
That's the initial. So how we got the 30 in the first place is we said the initial displacement is final minus initial is displacement. 30 minus 20 equals 10. 30 we got from 10 plus 20. Yeah. I see you okay, yeah. Yeah, Jamal. Okay, so do you remember how I said to find the area of a trapezoid? to J is 16 meters. The answer to J is 16 meters. Note, by the way, there's more than one way to do this. You could split this into time 0 to 1 second and time 1 to 2 seconds too. The first trapezoid is 10 meters, the second trapezoid is 6 meters. If I'm to split them up into 3 1-second intervals, what would the displacement in this third triangular 2? How do you know 2? Yes. So what's the total displacement in the full first 3 seconds? Where do you end up? 38. Good, good. So 30, then 36 meters, then 38 meters. Where are you after 4 seconds? Anyone willing to do that for the class? 36, very good. What do you think? 36? How do you know? Area below counts as negative. Think about why it counts as negative. If you've got a negative velocity, which direction you move in? Left or down or back. In the opposite direction is this motion. This triangle is not equivalent, congruent to this triangle, 2 meters, 2 meters, 2 meters, negative 2 meters. These cancel. You get back to the position that you were at 2 seconds. Questions? Follow-up questions? You've been braining hard. I am proud of you. You guys have been engaging. I've been listening. Maybe not every person on every single problem. Yeah, I know it's late, but I am hearing A-level engagement here. I am pleased. And I'm seeing on the participation form, people are engaging properly. Go ahead and go 8 minutes early. You've earned it. I am, aren't I?